Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So today we are going to present our assignment. We are from BMMA S11 Group E on the topic that has been given to us and that is semi-active suspension system. So our group members consist of 4 people which is ABDUL MOHAMMAD bin AZMI, AHMAD AMIRUL IMAN bin Rosli ANUR, Muhammad Akmal bin Rosli and Muhammad ARIF SYAMIM bin MAZLAN. So the introduction for our assignment is this. For this system includes a sensor that detects bump on the road and movement of the vehicle, and a controller that controls the damper on each wheel. The semi-active suspension can respond to even slight variations in road surface and to cornering. The use of semi-active suspension in particular is extending beyond top-end models to also include small, low-cost vehicles with performance improvements being achieved through integrated control in cooperation with other chassis control systems. The system obtains a high-level ride and handling performance with low energy consumption through real-time damping control. It is part of chassis control system which is also called vertical direction control. So in our assignment, each of us have our own journal that we have reviewed. So for our literature review, the first title and the first journal is State Estimation and Damping Control for Unmanned Ground Vehicle with Semi-Active Suspension System. The second journal is a study on a vehicle semi-active suspension system control based on road elevation identification. The third one is Adjustable Valve Semi-Active Suspension System for Passenger Car. And the last journal is the Semi-Active Suspension System from Research to Mass Markets.
I am ABDUL MOHAMMAD bin AZMI. Will present about the state estimation damping control for unmanned ground vehicle semi-active suspension system. Okay, there is 4 methodology for this journal. First is dynamic model. Dynamic model is to investigate the performance of the state observer and control strategy, a quarter car suspension model with a non-linear S-spring and continuous damping control damper. Okay, second methodology is feedback linearization for the non-linear suspension vibration observer design. It is an appropriate non-linear transformation of coordinate could be established so that the original non-linear system can realize the precise feedback linearization. Okay, number 3 is feedback linearization Kalman observer design for the linearized suspension system. It is considering the process noise and measurement that exists in the system. We can get an observable normalized form with system noise. Okay, lastly for methodology is a model reference sliding mode controller design. It mainly contains a skyhook reference model, sliding mode controller and a quarter car semi-active suspension system. Okay, for the result, there is 2 results from the observer performance and the controller performance. Okay, from the observer performance, in order to evaluate the performance of the process non-linear state observer, a quantitative model method which is usually used as judgment of the performance was induced. Just because the sprung mass deflection is not the exact system state of the design observer, it cannot be estimated directly and have to go through the integration of the estimated sprung mass velocity. So the estimation error would be accumulated during the integration process. Okay, by the contrast, it can be found that the proposed feedback linearization observer can estimate the sprung mass velocity, unsprung mass velocity and suspension deflection precisely. Okay, from the controller performance, there is 3 different operating modes during the simulation period. First is SMC ORI, second is SMC FLK, and lastly SMC ESK. It is obvious that the dynamic response under the SMC FLK controller is very close to that under the SMC ORI controller, while the vertical vibration under SMC ESK appears more unexpected larger peak values, meaning a worse ride comfortability, which is apparently caused by the distortion of the estimated states existing in the SMC ESK controller.
Assalamualaikum warahmatullahi wabarakatuh. I will present a journal about a study on a vehicle semi-active suspension control system based on road elevation identification. Okay, for the methodology, first point is pavement elevation recognition method. To improve the road elevation perceptibility of vehicle, this study proposed a continuous multiple scanning recursive matching algorithm based on single line LiDAR sensor. LiDAR is a type of radar that functions in the optical band by sending measurement laser pulses to the target and then receiving the laser signal reflected from the target. The distance information of the target is obtained according to the speed of light and the propagation time between the LiDAR and the target. There is two methods for studying the control effect of suspension system. The first point is simulating control model, and the second point is displaced real-time simulation system. Next point is design of semi-active suspension controller. A diagonal recurrent neural network (DRNN) is a simplified and fully reconnected neural network wherein no information is exchanged among the unit in the hidden layer, which significantly simplifies the model and ensures learning speed and the model suitability for the control requirement of semi-active suspension. Okay, we go to the result. The first point is radar recursive scanning is used to obtain the multiple superposition data of echo signal, and coordinate matching is realized between historical scanning data and current scanning data. Simultaneously, the sensor height deviation and pitch angle deviation of the sensor are regressed to obtain an accurate pavement elevation. And lastly is the result of a hardware in the loop CO simulation, which was conducted based on the simulated control model and displaced real-time simulation, revealed that the ride comfort and stability of the vehicle will improve, owing to a preview of the elevation information of the road ahead and the active adjustment of the shock absorber of the suspension system. Okay, thank you.
I will present about the third journal, which is the adjustable semi-active suspension system for passenger car. So for the methodology for this journal is research on semi-active suspension system with adjustable valve for passenger car. So an electronical controllable damper was proposed to adjust the damping force that can suit the different conditions of road to achieve the required performance. The limitation of the passive and manual adjustable damper is investigated by analyzing the damping characteristic. The effect of the bleed orifice in fluid flow was estimated to offer a deep understanding of working fundamentally. The damper composed of a stepper motor that can help to realize the properties of semi-active control. The working condition of a vehicle employing controllable damper is analysed with the various types of settings. So, analysis of electronically controllable damper. The damping through the internal piston is dictated by the area of the orifices and the stiffness of the shim stacks, whereas the flow through the bypass valve depends upon the adjustable displacement pin that is controlled by the application of voltage. So the working principle for the damper is the valve is composed of a circular ball detent that allows a change in area from 0 mm to 7.07 mm. A slider was used to vary area according to the input pulse to the stepper motor. Changing the position of the orifice are categorized into 4 states. These states refer to adjustment from soft to hard respectively. So for the result of this that is obtained from this journal, based on this testing, there are changes in acceleration were obtained is lower than the comparable state of the ART semi-active dampers. There is a great range in response when the bypass hole is fully open and fully closed. The root mean square acceleration RMS was calculated and compared with standard values of RMS to determine the ride comfort and quality. The changes in acceleration obtained were lower compared to different adjustment of damper. Thus, the result of RMS for adjustable semi-active suspension shows ride quality and comfort lies within the range of a little uncomfortable and fairly uncomfortable.
Hello, my name is ARIF. I would like to present my literature review for the journal I have chosen. Let's take a look at my methodology that I discovered in the journal. Classical control strategies for semi-active suspension system. Skyhook control to reduce the effect of disturbance that cause the vehicle body to oscillate. The system compression and rebound damping are increased or decreased depending on the direction of motion of the vehicle body. Ground hook control, it consists of increasing damping and then decreasing deflection to reduce road tire forces. Hybrid skyhook, ground hook control. By combining the skyhook and ground hook control, this logic aims to reduce both body acceleration and dynamic tire force. Next is modern and intelligent controllers for semi-active suspension system. Optimal control. The three control laws that comprise the linear quadratic State feedback control are A. Full state feedback, B. Limited state feedback, and C. Skyhook damping. Modal predictive control (MPC hybrid). To derive an optimal control law for semi-active suspension system, the constraint quarter car semi-active suspension is modeled as a switching affine system with switching determined by passivity, constraint activation, force saturation, and maximum power dissipation. H. Infinity clip control. The force applied by the semi-active damper is then chosen to be as close to the force required by the controller for a given suspension deflection speed and force range as possible. Fuzzy logic control (FLC) to control non-linear systems that are mathematically difficult or impossible to model. Furthermore, it does not require precise, noises-free inputs and can be programmed to safely control the system if the feedback sensor fails. Next part is the result. Following the review of previous research studies on the semi-active suspension system with a focus on the control suspension system in the automobiles market, it is possible to conclude that solenoid valve dampers as a semi-active dampers have been developed and commercially available. Semi-active control algorithm, typically based on the skyhook control strategy, have been developed by suppliers or OEMs to achieve the proper balance of ride, comfort, and road holding controls. Lastly is the conclusion. Based on the 4 journals that we studied, we can conclude that semi-active suspension system provide not only vehicle ride comfort and control, but also better road holding. Besides, a semi-active suspension is a compromise between the simplicity and cost of a passive system and the performance and comfort of an active system. It uses sensors to continuously monitor the road condition and the motion of the system and adjust the damping and stiffness of the suspension accordingly. This allows the suspension to provide some of the benefits of an active system without the added complexity and cost. Thank you.